Hello friends, welcome to Math Master Studio where math made easy. Today I am Omkar here again going to explain you basic proportionality theorem. So let's go and write down the theorem. So as we look at the first of all let's look at the statement. Okay, basic proportionality theorem. The statement is if a line is parallel to a side of a triangle, okay, we have here ABD as a triangle and EF as a line parallel to the side BD. If a line is parallel to a side of a triangle, intersects the remaining sides. What are the remaining sides? AB and AD, and the line EF is intersecting the remaining sides AB and AD in points G and H respectively. If a line parallel to side of a triangle intersects the remaining sides in two distinct sides and in two distinct points G and H, then the line divides the side. The line EF divides the sides AB and AD in the same proportion. What does that mean? That means that AG upon GB is equal to AH upon HD. Okay, the theorem is saying AG upon GB will be equal to AH upon HD on the condition that the line EF is parallel to the line side BD. Okay, whenever you look at the statement of the theorem, friends, whenever you look at that, there are two parts. Okay, and then if and then there are two parts. So if we look at the if part, that is the given for us. Okay, and when you look at the then part, that is to prove. Okay, in whatever the theorem you are studying, or in whatever the standard you are, and whenever you are stated to prove any theorem, given and to prove, all that is given in the statement only. So try to remember the statement, or the try to read the statement very carefully whenever you are reading this theorem. Okay, so as I have said, we have given in triangle ABD the line EF is parallel to side BD, and the line EF intersects sides AB and AD in points G and H respectively. Okay, so now let's move to the next, that is to prove, as I have said, the part after then, that is AG upon GB is equal to AH upon HD. This is what we have to prove. Okay, so what is the construction? What we have to do in this theorem is we have to join these 2 points G and D and the H and B, opposite points between two parallel lines we have to join. Okay, so what we get is two triangle HGD and GHB. Okay, so now let's look at the proof. Okay, what the proof says is, how we have to prove this theorem is a basic simple funda. Okay, remember the simple funda, whatever I am going to tell you now. The funda is that this triangle AGH, and we have to take that as a common, and these two triangles. Okay, so basically what we have to do is we have to prove take the ratio of the triangle GHB and AGH, and the same way we have to take the ratio of the triangles area of triangle GHD and AGH. Okay, as simple as that. First of all, we have to use these two triangles, and then we have to use the other two triangles, okay, with the triangle AGH as a common. Okay, so now in triangle, as I have said, in triangle AGH and triangle HGB, what we have is both the triangles have equal heights. How both the triangles are having equal heights? What we can say, that how we can prove that, if we consider the AG and GB as the bases, then the height must be the perpendicular to the base. Okay, now for your convenience I have drawn the two triangles separately. Here we have got AGH, this one, and we have got GHB, this one. Okay, so now if we draw the height of these two triangles from a point H, then what we can say, or what we can say here, OH is perpendicular to the base AG of triangle AGH, as well as OH is perpendicular to the base AB, or what we can say that OH is altitude of the triangle HGB as well. Okay, so here you can clearly get the idea of how both the two triangles, triangle AGH and HGB, have equal heights. Okay, now let's, so what, why we are trying to get this is because, being, since they are having equal heights, their areas, our area of a triangle is half into base into height. So since having equal heights, the areas will be definitely proportional to their bases. Okay, this is what I have written here. The areas are proportionate to the bases. So area of triangle AGH upon area of a triangle HGB is equal to AG upon GB, AG upon GB. Okay, because having equal heights. Okay, so in a similar manner, area of a triangle AGH and upon area of a triangle HGD, we can say that AH upon HD. Again the same heights, so areas are proportional to their bases. Okay, so now we have got these two results. Now next, let's move to the next. Next is segment GH is a common base of these two triangles. What it is saying is, segment GH, this is segment GH, it is a common base of the other two triangles. Now we are considering the triangle HGB and HGD. Okay, both the triangles are having common base as GH. Also, since EF is parallel to side BD and these two triangles are included in these two parallel sides, so if we draw the heights of the two triangles, then we can say that both are having the same heights, because those are included in the two parallel lines. So triangle HGB and HGD have same heights. Okay, this is what is the statement is saying. Segment GH is a common base, GH is a common base of triangle HGB and HGD. And since segment EF, this is segment EF, is parallel to the segment or the side BD, if we draw the heights like this is the height of a triangle HGB, HGD, and this will be the height of the triangle HGB. So both the heights will be equal, both the bases, both triangles are having same base GH. So we can say that since the area of the triangle is half into base into height, we can say that area of a triangle HGB is equal to area of a triangle HGD. Okay, this is our third result. So from 1 to 3, what was 1 is, if we look at these two and if we try to, since we have got the result, area of a triangle HGB is equal to area of a triangle HGD, so what we can say that these two are equal, these two are equal. Okay, we can say this. So AG upon GB is equal to AH upon HD. This was what the result we are supposed to prove. Okay, hence our theorem is proved. So simple, friends, what it is saying, again I am concluding the theorem with EF. If a line is drawn parallel to a side of a triangle intersecting the other two sides in two distinct points J and H, then the line EF will divide the triangle ABD, or divide the other two sides AB and AD in the same proportion as AG upon GB is equal to AH upon HD. Okay, hence our theorem is proved. Friends, if you have any doubts, please don't forget to write in the comment section. And if you have got thank you, thanks a lot. This is the end of the basic proportionality theorem, friends. If you have any doubts, any suggestions, please don't forget to comment, and if you want to clear more and more of theorems, please subscribe to my channel and keep updated. And look at the other videos as well. The links of the other videos are mentioned down in the description. And thank you so much, friends. Thank you for watching. Thanks a lot.